After building this wind tunnel, we used to, while it was still permitted, really test quite often with a full-size car in the tunnel. If you have the money, why wouldn't you? The advantages that had were mainly that we were testing with real parts, full size, high speed, and that the car would then deform in a real way under aerodynamic load. And the main downside to that was the lack of a genuine cornering simulation, and also, honestly, the cost. We also did straight line testing, an airfield type track, no blockage effect, lots of data from one set of constant conditions. That gave us additional information. Averaging data over a long time makes the data, if you like, more repeatable. But again, we had no real corners. Then track testing is the closest to racing, but in a test, you're also able to control if someone is directly in front of you. You can find yourself some clean air without giving away a position. And that has some real advantages. However, conditions such as the weather, the state of the tyres, the consistent behaviour of the driver, they're things that are changing. However small, they're changing. However subtly, they're changing all the time. So track testing is the most realistic way of testing, but it's also the least repeatable because of these changing conditions. And track testing also wears out the powertrain, wears out the tyres, and so costs much more than other research methods. Model testing costs less. Models look smaller than their linear scale, at least to me. If you see a model, I believe what you see is area. So a 60% model, you see 36%, comes out at 36%. You see 60% of the width, 60% of the height, if you like, and that looks like a bit more than a third of the size of a real car. And for me, that feels correct. It feels definitely smaller looking than a half-size car, even though it's bigger than half scale. Now, for a 60% model, the volume of material that you need to make the parts is 0.6 times 0.6 times 0.6, which is, in percentage terms, about 21.5% of the volume you'd need if you were making a real part. And the same applies if you take a block of material that's the right size for machining a part from, say, a block of metal, then the same rule applies to how much metal you have to remove from your block. So the cube of the scale, if you like, that 21% for a 60% model, relates quite closely to the cost of making parts. So model testing costs you much less to make the parts. Another reason why teams used model testing is that in truth it wasn't possible until, let's say, relatively recently to put a race car in the tunnel and do realistic testing with a moving ground system, let's say 12 years ago. So before that, model testing was also actually more accurate than real car testing, because you're able to do a proper ground plane simulation, which with a race car in the past wasn't really realistic. But now it's really a cost thing that had kept teams using scale models. Now a 50% scale model would need only 12.5% of the volume of a real car. So, and that's about 70% more. If you started with a 50% model, you'd need about 70%